Hi, welcome back to a new episode of the Hardware Legends and at the same time also a new episode of the viewer mail. And the reason for that is that Sebastian contacted me. Thank you very much at this point for the opportunity to test your equipment. And he had this very nice kit of an 8800 GTX from WinFast, or I don't know, Leadtech. We'll have to look it up what the exact description for this thing is. And this should be a like 15-year-old or 10 to 15-year-old combination of an 8800 GTX AIO cooled. So that is a very early attempt of AIO cooling a graphics card. And I'm very curious to see how an AIO cooled graphics card looked like back then. The cool thing about this is that this kit is actually not working. So his cooling solution is working, or that's what he said, and you can even hear the water in there. Very curious how it will look inside there. Yeah, we will find out. But the GPU is broken. Now the cool thing is that I also own one of those cards or kits, this exact same model, and you can see it's already taken apart because for my model the card is working, but the cooler is not working anymore. I think the pump was dead, and I kept it in my basement for, I don't know, like 10 years, feels like it. And now that he contacted me, it was like a nice coincidence that he was looking for a working card. And I have a working card, but the AIO cooler is not working. So my goal will be to just out of those two broken, like partially broken kits, I will reassemble one working one if everything works out. And then he will get the working one in return that we were allowed to use it for the video. All right, very curious to see how this thing looks like inside, because I think in the last 10-15 years, there is certainly, there were some changes in the AIO market and how they attempted to have like water-cooled GPUs, and yeah, very curious how this thing looks like from inside.
Caseking, the heart of your system.
We will start with my kit because obviously there is no water inside, it's already drained. It will make it easier to first disassemble the card and then also disassemble the cooler separately. Will make it a little bit easier. I just also noticed it was not an 8800 GTX, it's an 8800 Ultra, because I maybe said that wrong first. It's a Leadtech WinFast Leviathan. Yeah, I think it was back then one of the fastest, or maybe the fastest 8800 Ultra. It was damn expensive even for today's standards. And yeah, we will first start with disassembling the card itself. And just by looking underneath this cover, you can already spot that this should be an aluminum-based water block. Back then, a lot of those cards, or like a lot of water cooling components, were aluminum-based, especially from like Innovatech. That was a big water cooling company at the time, using a lot of aluminum blocks, which is not really a problem because, I mean, it's a one closed cooling loop system. And then if you don't mix the components, if there's like no copper core or like copper, I don't know, fittings, then just using aluminum itself should be no problem. But yeah, first step will be disassembling the card itself. To keep things short, I just removed those screws, and now we have the water cooling block from the underside. And yeah, Sheik also joined us, but already falling asleep. Anyway, here we have the PCB of the 8800 Ultra, or also 8800 GTX. Both shared the exact same design, same PCB. It's just one reference design. We have the G80 GPU in the center. I'm going to clean it off the thermal paste in a second. And the thermal paste is, thermal paste is still okay. Even after I checked it, it's 13 years. This card is 13 years old, and that's quite insane. We have the memory surrounding the GPU. It's GDDR3, and it's a 768 megabyte. It's quite less compared to nowadays. And in case you're wondering, this chip sitting next to the GPU and close to the output is something that's called RAM DAC, I don't know how to call it exactly, but it's a digital analog converter, which is converting the digital signal from the GPU to the analog output for your monitor, in case you're wondering. Now, after removing the thermal paste, we can spot the beautiful G80 GPU. It's also labeled with Taiwan, and it's made back then by TSMC, which you all know from nowadays AMD GPUs or AMD CPUs. Back then, this was made in 90 nanometer, and it has a transistor count of about 700 million transistors. And if you compare that to a nowadays RTX 3090, which has about 28 billion transistors, that is just quite a huge jump if you compare that over the 13 years. I didn't think or didn't expect that they were using a hybrid design, but yeah, it's a copper core and surrounded by an aluminum block, which is rather unusual nowadays, but back then I think you didn't have that much experience in like mixing metals and not sure like what the structure will look like inside if anything is blocked, but we will find out. We will disassemble this thing in a second, but first of all I will just remove all the residues from like the thermal pads and the thermal paste. Cleaned off the residues, it makes a better impression. Also, if you pay attention to how the aluminum surface looks like, you will notice that this has to be some kind of injection molded aluminum part, which also indicates that there was a certain volume behind those cards. Usually it's only worth doing such injection molded parts from like, I don't know, above 1000 pieces, otherwise CNC milling would always be cheaper. And that is kind of surprising that they sold so many of those cards. First of all, we will now remove those fittings, quite interesting fittings. I mean, there's like a screw fixing those, and then let's see. I already removed the first fitting, and you can see there's a ton of weird stuff coming out of this connector, and it's also the first time that I've seen this kind of design for an angled 90-degree fitting. It has this rotary part, like this part is rotary, and you have a sealing on here and a sealing on the bottom, and then it's always sealed no matter how you turn it. But yeah, the water always has to squeeze itself like around this part on top, which will not lead to the best flow rate, but I guess for this kind of design we'll be fine. Let's check out what kind of nasty things we can discover under this other fitting. Yeah, there is a ton of corrosion going on. It's a lot of weird stuff on those connectors. Not sure how it's going to look inside. My first idea was to remove the cover, but then I saw that there is some like sticky foam in between the cover and the water block itself, which is keeping it together. You can also see it allows the water block to move to a certain degree, but it's also very sticky, and yeah, I don't want to ruin it, like want to remove the cover, because I don't think we can get it back on in the state it is right now. It would make things a little bit easier just to disassemble the water block and investigate things further, but I will just remove all those Phillips screws and then look how it looks inside. Leatech definitely did not cheap out on the screws, well, at least the amount of screws, but yeah, just removing the last ones, and I hope that nothing of this is like sticking together. Like corrosion could always like glue a cooler like this together, but we will find out in a second. Oh my god. Ach du Fu. Seriously now, like over the years I've seen things. I've seen pretty bad things and pretty bad things, but this is a different level. Like, can you see that this is like sand? There's like a lot of metal oxide parts, even worse down there. Not even sure if you should touch this stuff, but that is probably the worst cooler I've ever seen in my entire career. This is insane how bad this is. What is kind of interesting about this is that the areas where it's so damn bad are like the dead zones. So the water would flow like through here and then back out of the other connector, right? And then we have this like dead zone on the bottom right here where you would still have water. It's not sealed, but it's like a dead zone. There's like no flow rate in this part. And there's also like no flow rate in this area right here. And those are the areas where we had this like insane amount of whatever stuff like metal oxides building up. And the reason for that, or like this looks like the pathway looks rather clean. The reason for that could be that the previous owner, because I bought this used, the previous owner could have flushed this over the years. Like, I don't know if he ever cleaned this because the temperatures might have been terrible in between. But that result, oh my god, that is awful. And you cannot even tell anymore that this used to be copper. It just looks all the same because of all those corrosion and oxides building up. The only cute thing or like a nice looking thing is this passive cooling block, which looks like this old Nvidia logo from like 15 years ago, which was to cool this RAM DAC chip. But oh my god, that cooler is that is insane. One quick update before we continue with this thing. I just sent a message to Sebastian because I want to know that, or I want him to be aware of the situation of my cooling block, and I want his permission to completely disassemble his card. I don't want to return his card in this kind of state, or like knowing that this kind of stuff could be sitting inside his block. That would not be great. That's why I think it would be the best to just wait for his feedback and then probably like completely disassemble, perfectly clean it. And if you have any kind of suggestion or idea how I could perfectly clean this aluminum block, that would be appreciated. Maybe let me know in the comments down below. I decided to also just take off the cold plate. It might be easier for cleaning off the other card. We can test everything out on this sample. I think that is a good idea. I mean, it looks pretty awesome from this side, the copper right here, but from the other side, yeah, not so much. Pay attention to the top right corner. It looks like the corrosion ate itself through the block and also through the like O-ring, sealing ring. I'm also not sure if it was leaking, maybe partially, but yeah, the corrosion did some enormous damage to this cold plate. Damn. Let's go over to the rest of our AIO, this massive plastic block with the Leviathan logo on it, and you can see there's the 12-volt Molex power, and we have the fan connector, which probably goes to the graphics card or your main board, and then the fan, which is kind of ventilating this aluminium radiator, which, I mean, aluminium radiator would be fine if it would be a full aluminium block, but with this, yeah, not a good idea. Then we have this mesh right here. Yeah, you can see through a little bit, and there's another mesh on here. Quite interesting design. I'm not even sure how you were supposed to mount this. Like, were you supposed to mount this on like the exhaust of your case? Like this way? I'm not even sure. It's a very strange design. After removing the first cover, you can see the aluminum radiator underneath and also the fan with the cover and some nasty like dust sitting inside, which is usually happening if you're smoking next to your PC. I'm a non-smoker, like I never smoked in my life, and definitely not from me, but from the previous owner, I would guess. Now, there are some more screws, and I think after taking them out, we can maybe completely disassemble it. I have to admit that I'm quite impressed by the design of this part. I mean, the radiator itself doesn't have an enormous amount of surface area, and I don't know how this can have like a huge benefit over a big air cooling block, but of course, if you compare it to back then 8800 GTX or 8800 Ultra stock cooler, it still has a higher surface area, I suppose. And then you have this massive like reservoir on here. That is absolutely cool because it would keep a lot of water in there. You would not have to refill it like very soon. That is a quite nice design. We have a solid tube exiting the radiator, and then it's like getting inside the reservoir. Not sure if we can open this. We will definitely check that out. And then that is not a bad pump, I think. At least looking at the design, this could even have more power than nowadays AIOs. Not bad. Completely disassembled everything right now. The reservoir is made out of aluminum, which is kind of interesting, and yeah, but just look at maybe right here. Yeah, you can see there's still a lot of stuff coming out of from the pump, and probably also from here. Probably going to check out this screw and see if we can take a look inside of this thing, but I think corrosion just completely ruined this entire thing. I'm wondering what kind of steel or material they used on the screw. This looks like 40 years or like 50 years old. Damn. Yeah, let's just cut this open. Let's take a look inside. Look at all that nasty stuff inside. I mean, part of this will be like the residues just from cutting it open, but yeah, look at those big parts. I first thought if this would be a waste, like cutting it open, because it's like a collectible, this GPU, but everything in here is so damaged, like everything is so corroded, it wouldn't make any sense to keep it. When I first thought about shooting this video or just thinking about the cooler itself, I obviously had an idea that it could look kind of nasty inside, like there should be corrosion after so many years, but I did absolutely not expect it to be this bad. It was kind of interesting to see the cooling and construction approach they did like 13 years ago. It looks more like automotive tech than PC tech nowadays, but yeah, result is not good at all. Also, I just also tried to disassemble the pump, because there is definitely also some stuff inside the pump, but disassembling this part is not possible because it's glued together and it just broke apart when I tried to disassembling it. And yeah, if we get feedback from Sebastian about his sample, like if we're allowed to completely disassemble it, then we will definitely do it in another video. If you have some kind of ideas or feedback how we can like flush the entire loop and maybe somehow get rid of some parts of the corrosion, if you have any ideas of what kind of materials to use, please let me know, because especially like the reservoir and the pump are parts we cannot open. The rest is fine. I mean, if we open the water cooling block itself, this should be safe, because we can, worst case, we can even use like a Dremel and sandpaper and stuff to clean it. That is fine, but yeah, the parts we cannot open, also the radiator, that could be rather difficult. Please let me know if you have any feedback. Otherwise, I think it was impressive to see how wrong it can go. Thanks for tuning in. See you next time. Bye bye.